Today we're going to talk about rational expressions. And okay, so what are rational expressions? The word rational in math means something that can be written in the form of a ratio, like a fraction, something over something else. So a rational expression is an expression that's got like a numerator over a denominator. So here's one example of a rational expression that I found in just an example problem I found in one of my math textbooks. Here, this is supposed to represent the percentage of the normal level of oxygen in a pond, where T is the time, how many weeks it's been since some organic waste was dumped into the pond. We don't have to worry about the details of exactly what's going on here. I just wanted to show you an example of a rational expression that stands for something that you might encounter in the real world. But what makes it a rational expression is it's got something on top over something on the bottom. It's like a fraction, not just of numbers, but involving a variable, in this case t. In case you're curious what the answer to this question is, if you plug in various numbers from 0 to 5 for t and do the calculations, this shows what you get, but that's not the main focus for today. The main focus for today is what kinds of manipulations or calculations or operations you can do with these rational expressions. So basically, we are going to be putting together everything you know about how fractions work with everything you know about how polynomials work. So there's a lot going on in this section. We're going to be focusing on expressions that involve variables, but let's start simple with a nice, simple, innocent little numerical fraction, like 35 over 55. Now, that can be simplified. It's not in lowest terms, so we can reduce it. How does that work? Well, I see a 5 on top, and I could cancel that with a 5 on the bottom, right? And then it becomes 3/5. So 35 over 55 is equal to 3/5. Wrong. That's not the way cancellation works. You can't just see something on top and something on the bottom that look the same and cross them both out. Here's the legal form of cancellation. I could start with my 35 over 55, and I could say, well, 35 is equal to 7 times 5, and 55 is equal to 11 times 5. So I've factored them and broken them up into things that multiply together to give you those numbers. And now we are allowed to cancel these common factors of 5, and we are left with 7/11. And that is correct. 35 over 55 is the same number as 7 over 11. If you don't believe me, you can check on a calculator that will simplify fractions for you, or that will just show you what they are in decimal form. 35 divided by 55 is 0.6363 repeating, and 7 divided by 11 is that very same number. So they represent the same number, they're just different ways of writing the same fractional amount. So notice what we did here. We took our fraction, we factored the numerator and the denominator, and then we looked for common factors that we could cancel out. So that's the procedure for reducing a fractional or rational expression to lowest terms. Factor the numerator and denominator, and then cancel, which means what you're really doing is dividing out any common factors that appear in both the numerator and the denominator. So let's start with an easy one. This is easy because it's already factored for us. On top we have x minus 3 times x plus 2. On the bottom we have x plus 5 times x plus 2. Can you see what we can cancel? Yeah, there's an x plus 2 on top and on the bottom. We can divide those out, so canceling those really means we're taking the numerator divided by x plus 2, we're taking the denominator divided by x plus 2, And so what we have left is x minus 3 over x plus 5. That's equivalent to what we started with, but it's simpler. Okay, how about this one? X squared plus 2x minus 15 over 2x squared plus 11x plus 5. So the first thing we got to do is factor the numerator and the denominator. Now I'm just going to go ahead and show you what the factors are. If I were doing this live in real time, I might have to stop and think and figure out what the factors are. So it kind of looks like I immediately see the factors because they're obvious, but it's really because I figured them out ahead of time. So I'm not going to spend a lot of time in this section going over how the factoring part of this works. I'm assuming you already know how to do that. If you're weak on factoring, that's going to be an obstacle for you in what we're doing in this section. So in that case, you might want to go back and review your factoring. But when you factor the numerator and the denominator of this expression, the numerator factors into x plus 5 times x minus 3, and the denominator factors into 2x plus 1 times x plus 5. Do you see anything we could cancel there? Yeah, how about the x plus 5s? And then what's left? X minus 3 over 2x plus 1. So that is our final answer. We've reduced it to lowest terms. How about this? 2x plus 4 over 2x plus 6. Now what we can't do is cancel out the two x's. They're not factors. Neither the numerator nor the denominator is 2x times something else. But what we can do is we can factor out the 2 that the numerator has as its greatest common factor. And we can also factor out a common factor of 2 on the bottom. And then we can cancel out those common factors of 2, and we end up with x plus 2 over x plus 3. How about this one? 24 minus 4y over y squared minus 36. Okay, start by factoring the numerator and the denominator. On top, we factor out a 4 times 6 minus y. On the bottom, this is a difference of two squares, y squared minus 6 squared, so it factors into y plus 6 times y minus 6. Do you see anything we can cancel? Well, I see a 6 minus y on top, and I see a y minus 6 on the bottom. Are those the same thing? Not really. Because with subtraction, the order matters. If they're in the opposite order, they're not really the same thing. But they are related. They are opposites of one another. And we could pull out a factor of -1, and then they would be the same. So if I do that on top, instead of writing it as 4 times 6 minus y, I can write it as 4 times a negative times y minus 6. It's the same thing if you multiply it back out. You still get a 4 times 6, or a negative 4 times negative 6 is a positive 24. And you still get a 4 times a minus y, or a minus 4 times y is your minus 4y. But now, we do have something we can cancel. There is a y minus 6 on top, there's 1 on the bottom. Cancel those, and we've reduced it to -4 over y plus 6. So when you have factors that look the same except that the subtraction's in the opposite order, you sort of can cancel them, but you do get a negative out of that. How about this one? 75x to the 5th y squared over 25x squared y to the 3rd. Well, when you look at the numbers, the 75 would be like a 25 times 3. So we can divide out 25. So the 75 over 25 reduces to just a 3 on the top. X to the 5th over x squared reduces to x to the 3rd power on the top. And y squared over y cubed reduces to just 1y on the bottom. So in lowest terms, what we end up with is 3x to the 3rd over y. Because here's all the factors we started with, and we were able to cancel out that common factor of 25 and x times x and y times y that appeared in the numerator and the denominator, and then what we had left was 3x to the third power over y. And what about this one? X plus 7 over 2x plus 7. Can we cancel anything there? No, because we don't have any common factors. Beware the temptation to cancel those 7s. They are not factors. They're not 7 times something else. There's nothing we can really do to factor either one of these. So this is already in lowest terms. It cannot be simplified any further. Okay, so in this video we talked about reducing fractions or rational expressions to lowest terms. Next we'll talk about some of the other things we can do with fractional expressions, like adding, subtracting, multiplying, dividing, but I'll save that for the next video. We'll come back and talk about, first I'll talk about multiplication and division, because that's easier than addition and subtraction when you're talking about fractions.